Next, we'll go to project number 5, Micala, and I will turn it over to CY, who will present this project. Oh, we cannot hear you if you're on mute.
Hello, and does anyone can hear me? Does anyone hear me?
Hmm?
Hello.
Yes.
Hello.
Yep.
Yes, we hear you.
Okay. And hello. Good night, everyone. And my name is Chung-Yueh Lien. And my team's project is named Micala, a full-text search engine for integrating the radiology and the pathology data via the FHIR and the DICOMweb. And this is our teams. I'm sorry, I'm the captain, and we have four members. It's Lorex is the CEO at the CETA Tech Information Service, and the Chin-Lin and Chien-hsing are the graduate students at the National ImagingStudy University, and the Deng is the undergraduate students at the National Taipei University in the Nursing and Health Science. So our team's basic idea is we want to improve the access to the VNA underlying the standard ways. So we are trying to integrate the two departments. One is the radiologists, and the second is with the pathology. And we want to integrate some common data, especially in radiology. It's a medical imaging coding as DICOM, and its annotations and the radiology report. But for the pathology, it's a very new for the whole slide images encoding as well as DICOM format, and its annotation and the pathology report. So we want to integrate those cross two departments. So we can use the full text search engines that can type any text to find all of the data. And our slogan is Micala, and I says a medical image come, la 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 la, just like a Chinese word. Come on here. Yes, right. Okay, so on my mouse is not work. So at first things we are to create a synthetic data from SIIM servers. So we are using an open source is created by the Lorex. Is a FHIR universal conversion kit which can support a source template and the pre-process. Let's pick into a file bundle and upload a specified server very quickly. So we trying to fix 18 FHIR radiology FHIR documents stored in the SIIM FHIR servers, and we also do some redefinition. As first is a modified DICOM tag, including a session number, patient ID, patient name for the data consistency, and then we also create a new FHIR IDs in ImagingStudy and the DiagnisticReport resources. And then after we correct the data, we upload the new FHIR documents to the FHIR server, as well as upload the new DICOM file to the DICOMweb server. And we also create a file bundle and store them into a MongoDB for full text search. And there are 4 SIIM patients in 5 patients in our servers. So the second, we have created a pathology FHIR documents. And we created 3 FHIR diagnostic report and the ImagingStudy FHIR resources. And we have added 3 patients in SIIMs. It's Andy, Joe, and Sally. So we also modify the WSI DICOM tag and create a new ID for data consistency, and also upload the new data into the server. So now in SIIM's Hackathon data set, and Joe, Andy, and Sally, they have a pathology report and the WSI connect to the FHIR ImagingStudy. So this is our system architectures. At first, we are retrieve the data from the SIIM servers by the FHIR and DICOMweb protocol, and we have created new create or and fix the new FHIR resource and the DICOM object. We are just and upload to the Burni FHIR Server, as well as upload the DICOM to the Raccoon DICOMweb and FHIR Server. And our proposal is Micala. Micala will just integrate with another open source project named Bluelight, a web-based DICOM viewer. So we are upload the FHIR documents as a bundle format to MongoDB to enable the full text searching features by the MongoDB. And we have added conditions in the Micala. If the image belongs to a WSI, then we will switch the WSI viewer. If not, we'll switch a journal viewer. So because we are implemented by a standard-based way, so we can configure any just configure the DICOM server at the endpoint. So we can retrieve image from any DICOMweb server. Just switch. So we can change the configuration to switch to retrieve the data from SIIM server. And also this is a demo time. So I will show the demo very quickly. So here we just click here. Oh, just here. So we can type any kind of word that we can for search for in. I just a minute memory because I don't know how to pronounce this medical vocabulary. So we have just search. So now we have keywords hydropneumothorax in 3 report. So we just click this once, and on the left and right side there's a FHIR diagnostic report. So it's encoding a structural format, and we can view the report in the text field. So here we can just choose for cross verifications. I can search, yes, there is a hydropneumothorax word in the report. So we can also click it to connect to a FHIR server. So and then we have a reference the image studies that corresponds to this report. So on the left side is image studies. So we are reconstruct the endpoint and the DICOM study series instant UID to retrieve the thumbnail for each series. So there was a very quick shot to preview the series of the first one image in the series. So we can view the report we can open the viewer. So this is a Bluelight viewer, open source. We have developed it. So we have provided very basic the functions in medical images. So it's a needed time because we are in Taiwan, so have a little bit of traffic. So let me just for screenshots. Oh, maybe we'll try again. So we can see that will be a lot of DICOM waddles the communication here. So that's here. Okay. So here. So click it. Oops. And the second, we can return our report. We can have a view all of the. For example, this study has 4 series. We can click it and to view the structure of the FHIR image study. So we are return to our view. Our view have a basic functions, Rui-Jun and move. We have some clicks, and we can please the window level very quickly. And we have a basic function for a real time MPR. So let's just show very quick for the demonstration here. Just here. Okay. So we are returned to the display for the pathology. Okay, so we can just, for the pathology, we have a tabular word. So I have, oh, there's one pathology here. So we can click hit. So that is a pathology report in here. So we can click hit. We can just show the keyword is also exactly in here. Okay. So it also can review the image study in DICOM WSI in here. So we can show the screen, the thumbnail here, and then we can also report another DICOM WSI viewer, which is also an open source, is developed from us. So we can have a decoding the DICOM tag in here, and then we have just a room in and room out, and switch the series of this WSI. So
Hey, we're at 10 minutes. So
okay. So just this one. Okay. Thank you for your presentation.
Thank you. Let me turn it over now to the judges for 2 minutes of questions.
First thing is to say thanks for helping make the Connectathon truly international, especially with the time zone challenge I'm sure you had.
It is 3 a.m. in Taiwan.
Exactly.
Thank you for your dedication.
Yes.
Who do you see as the main user of this application? Is this more for the referring physician, the patient doctor who's looking through all of the different reports? Or would this be for the radiologist or the pathologist who's looking for relevant priors? Who do you see as the main user?
I think the main user will be researchers because many hospitals in Taiwan, they are building many research database, especially for the medical imaging archive. So they will want to systematically collect all of the clinical data, including report and the imaging from the hospital. So the document need to be structured and standardized. So perhaps maybe the FHIR will be a proper solutions to collect all of the clinical data. Yeah, of course, DICOM is obsolete because of 99% hospital they are on the DICOM format.
Can I first of all, great work here. Can I ask in terms of the term searching, is that just simple word search, or do you have any other rules-based decision making for negation and things like that when you were searching your reports?
You mean that just type any kind of word, or
I guess do you have a way to determine is that thing that you're searching for present or absent?
Right. So if the text in the report said not hemorrhagic, would it still find hemorrhagic?
In this version, we don't have these determinations. So we just very simple to find out if this word exists in the text. We don't have any kind of process which is there have or no, for example, a carcinoma. But in here we have in our previous version we have developed it on it. So this is our previous version. For example, I can say cancer. So they will be searched here. So we can find the keyword have a positive or negative. So they will have be processed for it. For instance, I can say negative, and the result will be here. So I can click here. So there will be cancer. So there's a normal cancer. So there will be a normal. Yeah. So perhaps maybe you have some.
Yeah, it looked like it picked it up in the field, right, for indication. So but I can imagine this can lead to a lot of great things. But thank you for answering.
Okay, thank you.
Thank you so much. That was Project 5 Micala.